All right, everybody, we're back for another day of the the Ubuntu Online Summit. It's the last day, so we're almost powering through. We've had some good sessions, so we're going to power through the last 4 or 5 sessions, and then we'll call it a wrap. So today we are talking about charm composition. Actually, let me read you what the schedule says: relation stubs and composition. I have no idea what that means. So Corey, why don't we start with what problem are we trying to solve, what we have now, and what stubs and composition will do for me?
Right. So, okay, so the problem that we're trying to solve is that, well, there's actually three problems that we're trying to solve. First off is that it is often very useful to, or would be very useful to be able to take one charm and use it as the basis for another charm without having to basically copy and paste everything in the one charm. For an example, in the big data charms, we want to encourage other vendors or groups to take the core bundle charms and extend them to, deploy their own specific implementations of the big data ecosystem. And it would be nice if instead of having to, fork an entire copy of our charms, if they could just layer, their small modifications on top of it in a way that is easily maintainable, and they only have to worry about maintaining the one portion that they are making that's different. Another aspect to that problem, another problem that we're trying to solve is kind of related, is that when a charm author creates a charm and they define a relationship that is going to be used by other services, they generally will create a protocol that the other service has to follow in order to interact with their charm. In a lot of cases, it's just as simple as, the other service should expect a specific set of keys or data. But in some cases, it could be as complicated as a back and forth, multi-step negotiation. So in the past, that's been handled entirely by the charm author just creating the one side of the negotiation and, possibly documenting what the other side should expect or what they should do. But in a lot of cases, even the documentation is lacking, and so it becomes a case of, if you want to interact with this with another service, you basically have to read the code that for that charm. And that's not ideal. It's not as maintainable as it should be. So I'll get into how we want to approach that in a minute. The third problem that we're trying to solve is that when you start out writing charms, it's really easy to think about, I'm creating my charm and I need my MySQL database. And so I'll just create a relation hook and implement that. And once I've got my MySQL, I'm up and running. But you very quickly run up against the problem of, well, I need my MySQL database, but I also need, a memcache server to, store some temporary or ephemeral data. So I now have to coordinate between two different relation hooks to make sure that I have the information I need to be able to realistically start my service. And then you might run into, well, I also need this particular config option set so that my application knows what domain it's going to be running under, so it can render its links properly, or something like that. So you quickly get into a case where you've got 2, 3, even 5 or 6 different dependencies that all have to be met before you can start different aspects of your charms application. And you could even run into the case where you might accept a MySQL database or a Postgres database. And so coordinating between all of those different combinations quickly becomes very difficult to conceptually understand what's going on, and also in the code describe exactly what's going on, and you end up with a bunch of either repeated logic amongst your relation hooks, or shared logic, but you have to have a bunch of if conditions and a lot of different things that get very hard to follow very quickly. So this the pieces of this talk, I guess, are trying to we're trying to address those three problems in a way that makes charms easier to maintain, easier to reuse, more apparent of what the charms are doing, and just in general encourage better practices. So to talk about the first problem. So the first problem I mentioned was that we want, it would be nice to be able to kind of build upon the work of others in the form of taking their charm and extending it with the minimal amount of changes needed to make it do what the new application needs to do. So something that an idea we kind of got from a couple of different areas, Docker being one of them, but a few other places use this concept of layering. So what we're thinking of doing is creating a system where you can a charm can define define the code and some metadata about the what it handles and how, and you can kind of run you can think of it as a compile step or a generate refresh step that will take that layer, the base layer, and then you define a minimal layer on top of that to change some things or add some additional behavior, and the generate step, the compile step, will combine those together into a complete charm. The benefit here is that while the complete charm is what needs to be pushed to the store for deployment, in your repository you really could just worry about maintaining the small layer that you are putting on top of the base layer, and the base layer can be maintained by the upstream charm developer. So for instance, in the case of the big data charms, we as the big data charmers can maintain the core charms and provide easily modified portions to tweak the different values that a particular distribution might want to change, and they can just maintain a charm that is basically nothing more than a couple of YAML files that say these are the values we're changing, this is the base charm, and this is how you combine them. And then whenever a change happens to either the base layer or the overlay, the charm can be recompiled or regenerated and pushed up to the store. And it makes for reviewing the charms very easy, it makes for maintaining them very easy, and it still gives you all the power and flexibility of the charm. Were there any questions about that part before I go on?
Not yet. James Page might join us in a minute. So it seems to me that your primary tenet here is reusability, and
right.
And actually, that seems to be like the major tenet, I guess, that you're really caring about, right? So.
Right. Yeah, we want to make it easy to reuse the work of other charm authors without kind of redoing or having to separately maintain a fork and worrying about always keeping your stuff in sync with the upstream.
Okay. So are you going to show us some do we have any pseudo examples, like how you would what would that look like? Do we have?
Unfortunately, I don't. This is still very much in the early stages. I know Ben had a prototype example, but unfortunately, I don't have that available.
Okay.
We can try and maybe get access to that later and put it up on the mailing list or something like that. But I don't have it now.
Okay.
So sorry about that. But the idea is pretty straightforward. You would just have a charm, juju generate command or juju generate refresh that would look at a metadata file, a composed metadata file that would tell you what the base charm is, and your charm would have bits that are defined in such a way, primarily in YAML, but also in code, such that they can, combine easily. I'm sorry, I can't give a more concrete example of how that'll work.
No worries. No worries. Part of the reason we're doing this is to kind of let people know where we're thinking to get feedback. Right. So if you don't have concrete examples, obviously it's too early for that, but that's... That's kind of why
Right.
we do this. Okay. Um,
Okay, so that kind of plays into the next aspect. The next problem we're trying to solve is that we don't want charm authors to have to read the code of the other side to be able to of their service relation to be able to figure out how to implement that relation. And so what we're proposing is to have the original charm author create both sides of the relation. They'll implement what we're calling relation stubs, one for the client side and one for the server side, so that it's well documented exactly, or sorry, it's codified exactly how the communication layer will act. And so then the client side will provide an API of some sort or simplified interface that can be documented that the new charm can use, and the parent upstream charm, or the kind of the provider side of the relation can use the provider side of the provider implementation, which can also be reused in other charms. So if we define, for instance, a database relation, we'll define a database client relation and database provide relation. And both Postgres and MySQL can use that, and perhaps extend it, or use it as a basis for a new relation, or whatever ends up being the proper approach there. So the big idea there is that both sides of the interface are going to be implemented by the charm author that originally creates the interface. And it's going to live outside or separately from any charms, and will just be used by the service that is providing and the service that is requiring. I do have an example of that, but I'll show it in a little bit because it ties in with the last part.
okay.
But the way that we're envisioning this working is integrated with the charm generate. So what we'll have is a base layer that most, if not all, charms should use. Excuse me. That would have when you use the charm tool to create a new charm, it will ask you some information about what relations you want to support, and it will be able to then define your interfaces and your metadata, but also pull in the appropriate relation subclasses as a base layer that your charm will build on. So it wouldn't necessarily be pulled in directly to your charm, but it would be set up as your base layer includes the MySQL relation client stub, or the MySQL relation server stub, or what have you. So that way you'll have access to these relation stubs without having to maintain them yourselves. But if you do need to work on those and extend them, it's possible using the composition feature. Okay, so then moving from that into the third aspect is you have multiple relations, or even relations in config, that all have create dependencies for your charm that have to be satisfied before your charm can do what it needs to do. So what we're envisioning is that the relation stubs will expose a sort of state or event type system, or perhaps probably both, where the relation stub, when it as it processes the back and forth communication protocol over the interface with the remote side of the service, once it reaches a point where where the relation stub knows that it has some useful set of information that such that work could proceed to be done with it. For instance, with the MySQL relation, once all of the bits, the host port, username, and password are all available, it can surface a state or an event state, a state event saying, we now have all of these bits of information. Your database is in a connectable state, and I think this is probably a good point for me to go ahead and start sharing my example here. So is that showing up okay?
Yeah.
Do I need to make it any larger?
No, looks fine. Yep.
Okay. So on the top here, what you'll see is what essentially would be a relation stub, the client side of a relation stub for MySQL. And you see that it has the cache keys. So, that's actually incorrect. That should be probably DSN keys or something like that. So this says it needs the host support username and password, and it uses some helper methods defined in the base relation stub base to say, do I have all of those keys? Are they ready? Are they available from the other side? If so, we're going to save that information in a way that can be accessed easily by the side using the using this relation sub, and then we're going to set the current state of this relation to db.connectable, and it uses current relation name so that it uses a name defined by the subcharm or the downstream charm. And then if it does not have the appropriate data, then it removes that state. So what that lets the downstream charm do is respond to those states. So it can indicate when the relation is in DB connectable state and my memcache relation is in cache ready state. Then I know that I have all of the pieces of information that I need, the database and the cache, to set up my config template, generate the template and or generate the config based on the template, render it, and then restart the service. And it's very, we feel it's very easy to follow what's going on here when you say when these two things are available, and these will end up being fairly standardized based on the relations. You can see that when these are available, this is what you do. And then conversely, when these are not available, then we know we don't have the information or the services that we need to support our service, so we can go ahead and shut it down. And presumably, we would say helpers dot status set blocked missing requirements, and we'll this is using the new extended status information that was talked about previously, to indicate to the upstream user, the Juju admin, that we're blocked on some missing data, and this sort of thing will probably be kind of built into the when and when not to some degree, maybe at least made a little bit easier, so you're not manually having to set the status like this. But so that's the basic idea. We kind of give these state events that allow you to have more semantically meaningful descriptions of what your charm needs and what it does, given different sets of state. And this also allows you to, in your charm, define new semantic states that are specific to your charm. So maybe once you have, DB connectable and cache ready, you'll surface a new event that says, service ready for, restart or something, more complicated. So you can chain these together and have cascading dependency trees in a very readable fashion. So let's say you had a secondary service that required your main service to be up, but then also required an optional, third relation to be set. Then you could surface here. You could say helpers dot set state app dot ready, and then down here you could say when app dot ready and I don't know, say HA proxy dot available already. Then you can define, setup with HA. Something like that. So you can chain the states so that you have not just able to describe the relations that you need available, but also a sort of dependency tree that allows you to kind of give more semantic meaning to what the different pieces of code might require before they can do what they need to do. Does that make sense? Any questions?
Looking in the channel here.
Yep. I feel like I went through that kind of quickly, and we're maybe ahead of.
Yeah, and James Page kind of abandoned you, so we don't really have a lot of questions. We do have 5 viewers though, so I don't know if we'll get some follow-up questions on the mailing list or whatever.
Sure. And these are kind of high-level concepts that we've been talking about for a relatively short period of time, but Ben and I were going to be starting work on these here pretty soon, because I really do think that the state event model is a very powerful way of solving a problem that we have historically been solving with the services framework, but the services framework has its own issues in that it creates a whole you have to kind of predefine ahead of time what your various blocks of behavior are, and it can get verbose kind of quickly, and it also tends to separate the the dependency, the requirements from the code that actually depends on those. So I think this gives a better
Do you and perhaps pointing people to a spec, I think, would get probably a lot more.
Yeah, I know Ben
feedback.
is. Ben's working on the spec, but I don't have the.
Okay, so the do-off for me then is to ensure that gets published somewhere that will generate questions for you guys. It's kind of yeah.
Yeah, and I'm sure we'd certainly like feedback as to whether there's any refinements to this approach that we can make to make things clearer to the people that are going to use it. But
right. Do you have any plans as far as have we picked like a kind of set standard hello world that you'll do first, or
well,
we could tell people these will be the ones that if worst comes to worst, just look at these and steal these.
Yeah, I'm definitely planning on using this in the big data charms, the core Apache Hadoop bundle charms. First, because and that code is generally refactored, I think, well enough that it would be a good example to look at. They're currently using the services framework, but I think using this new format will kind of make them even easier to follow what's going on.
Okay.
But I'm not sure if we'll come up with a perhaps slightly simpler example in addition to that.
Okay. So James Page is back. I'm going to ask him if he has any questions so far or any comments as far as what we've seen so far. Or from anybody for that matter. That'd be good. And if not, we could just wrap it up a little early, maybe halfway through.
So James mentions that there's a few OpenStack charms that he'd like to start getting using this approach. So that's another place where we could have some good examples, because I know those guys do some really high quality charms.
Absolutely. All right, and with that, I think the big do-outs here is especially when, since Ben's kind of the one driving this, I think the best thing to do here is to ensure that he just follows up on the Juju mailing list, which you could find at juju@lists.ubuntu.com, and hopefully we'll have a spec and kind of will explain it in a way to keep the conversation going. You know what I mean?
Yep.
Cool. All right, and with that, since we don't have any questions, we'll go ahead and break early, and we'll see everyone at the top of the hour for I'm doing providing cloud credits for free for people who are writing charms, so you'll want to see that if you're interested in getting free stuff. And then we're going to have a landscape demonstration, which should be a lot of fun for those of you not familiar with that. With that, thanks a lot, Corey. Thanks, Amir, for sitting in, and we'll see you guys later.